Module 11, Network Design. The main model objectives is a hierarchical network, and in this topic we will explain how data, voice, and video are converged in a switched network, a scalable network, explain consideration for designing a scalable network. So let's say that you have a network, you designed it like 5 years ago, now you want to make it bigger. So in this part, we will try to explain those things that you need to take care of it and consider it when you design a network, so it would be scalable for the next time that you want to make it bigger. Switch hardware, explain how switch hardware features support network requirements. So we have different type of switches, and we will talk about each one, and we will try to explain how each one is different from the other. Router hardware, describe the type of routers, of course, for a small, medium-sized business network. So we will try to explain more those routers that are for the small and medium-sized business networks, because we know businesses can have a very large network. So we will try to explain only the small and medium-sized ones. So 11.1, hierarchical network. So what do we mean by hierarchical network? First of all, there's a video that I have gave you in the slides, the link I gave you. You can take a look and you will have more details about this three-layer model network design. However, we will try to explain it in here also. Organizations increasingly rely on the network infrastructure to provide mission-critical services. So they will need a network so they can do their day-to-day jobs in their offices. And of course, evolving organization require network that can scale and support these four points. So if an organization now, before like 5 years ago, it was five employees, now it is 20 or 25. Of course, it is not a big deal. We can still manage. However, if it reached 500, it would be a lot. So we need to make sure that our network would support this. And of course, we need to make sure that our network support converged network traffic. So if there's a lot of traffic, it needs to support it. Critical applications, because sometimes the applications, the database or the financial systems need to make sure that you have a very good network. Diverse business needs, because sometimes you will have some needs. If the network cannot satisfy it, that would be a problem for you and for the network. Centralized administrative control. Sometimes in a building or in an organization, there might be some needs for administrative control, so you need to make sure that you design your network in a way that it can support the administrative control. Campus network designs include small networks that use single LAN switch. Okay, so campus network designs, it is not like a very big network configuration. Sometimes use a single LAN switch up to very large network with 1,000 of connections. So when we say campus network, we mean a very simple network that only consists of a LAN switch or one switch into a very large network with 1,000 of connections. Okay, so campus network is a very general term that we will use. You see, there's a point in here, borderless switched networks. The Cisco borderless network is a network architecture that connect anyone, anywhere, anytime, on any device. Of course, these three are very important: securely, reliably, seamlessly. Seamlessly means smoothly, so there would be no problem. Reliably, that you can trust it and you will not have any problem with the connection. And securely means that the data are in somehow protected. So that means this is the borderless network. When I say what is borderless network, it means that this network architecture can connect anyone and anywhere in any time, or any devices. So sometimes in anyone means any person that comes to your organization. You can create an account or give him a laptop and connect it to the network via VPN. We explained these before. It would be available for him to use the network and anywhere. It might be remote from another country, for example, and anytime. It means that your network need to be 24/7 available. as a server. And on any device, sometime that employee might use a laptop, sometime an iPad, or even with their mobile phone. So it needs to be provided. And securely means that the data that maybe for the credentials, user and password that the person uses, it should be secure and reliable and seamless. Reliable means that I can trust it. Secure means that my data are protected, and seamlessly means that smoothly. For example, it's just a user login. No need to make it very hard for the user. And of course, the Cisco borderless network means all of these. It provides the framework to unify wired and wireless access. Okay, so this one is a framework, or it will provide you a framework to make sure that you will unify wired and wireless access, built on a hierarchical infrastructure, okay, of a hardware that's scalable and resilient. Okay, so borderless network built on a hierarchical infrastructure of a hardware, of course. Those hardwares need to be what? Need to be scalable and resilient. Scalable means that you can make it bigger. Borderless switch networks are hierarchical, modular, resilient, and flexible. Of course, it's like it's just same as here. Borderless switched network. They are hierarchical, and they are modular, they are resilient, and they are flexible. We will talk about what each one means in these other sites. Now, hierarchical network use tier design of access distribution and core layers. What does it mean? It means that the borderless switched network have three-tier layer or two-tier layer. It means this. And so what does it mean, access distribution and core layer? The access layer is like in here. Let me grab a pen. Make it right, yes. So this is access layer in both sides, in the two-tier layer or three-layer, no problem, they both have. Now you see the difference, Ed, and we will try to explain in the other sides too, that they need to make sure that the hierarchical network uses the tier design of access, distribution, and core layer. You see in the three tier, we have distribution and core layer too, with each layer performing a well-defined role for the campus network. And each layer has its own responsibility. So for example, the core layer, the distribution layer, the access layer, they each one have their own responsibility. There are two-time tested and proven hierarchical design framework for campus network, and it means that these two, the three or the two-tier layer, they are both tested, and uh, we know that these two are like the best campus network framework that we can rely on. Now we will try to explain what does access and distribution and core layer means. And just a heads up, just so you know that in the two-tier layer, the core and the distribution layer are in the same place. However, in here, in the three layer, the distribution and the core layer are two different layers. So we will explain what is the job of each one and so on. Now the access layer, these are the access provided network access to the user. So these are the normal users. They can just like give them the user and password for the Wi-Fi and the SSID and the password for the Wi-Fi, and they can connect to it, and that would be it for them. And this layer, access layer, it will be connected to distribution layer. Well, it is kind of, we can see it from here. Now, this is the access layer and this is the distribution layer. These two are connected, and also in here, they are the same. We know that too. Now, the distribution layer, the layer implement routing and QoS. QoS means quality of service and security. So in exam, they might ask you that in which layer routing and QoS and security is implemented. Well, your answer would be distribution layer or distributing layer. And it aggregates large-scale wiring closet networks and limit layer to broadcast domains, of course. And in here, we know that the distribution layer switch connect to access layer and core layer switch. So it means that the distribution layer in here, it would be between the access layer and the core layer. Now, what is core layer? The core layer is the network backbone and connect several layers of the network. It would be the backbone. So, like, it is the must to have the core layer. Okay, and the core layer provide a fault isolation and high-speed backbone connectivity to make sure that you have a very, very good high speed and with the backbone connectivity and fault isolation. So if there was a problem, it would be only there. We will try to explain three-tier campus network and two-tier campus network. We said that we will try to explain what is the usage of two-tier and three layers. Well, here are the slides. A three-tier, we will explain three-tier. Used by organization requiring access, distribution, and core layer. If an organization or like let's say a company asks you to create a network for them and they say that we will need these layers, access, distribution, and core layers. Well, at that time, you need to use a three-tier campus network. And the recommendation is to build an extended star physical network topology. So you see that this is the star. Here's a point, and here's like its arrows. And from a centralized building location to all buildings on the campus. So it is from here and it is like a centralized building and it would be from here we will create a star physical star topology and we will try to connect to the other buildings. However, these building would be inside the same campus or the same place. So let's say that for if you created a network for like US University of Slemania, you will have a different faculties and they will all be connected to this to like a main building. And that would time the three-tier campus would be network architecture or framework would be a very good choice for this. However, the two-tier campus network, this one, you see that first of all, it is in the same building. Now, like it means that this one is kind of smaller or it's good for the smaller networks. And we will here talk about these in spread distribution and core layer is not required. Well, when they say, well, distribution and core layer, we can make it all in one device. We don't have a lot of like privileges and so on. So at that time, it would be better to use two-tier, and it is useful for smaller campus locations or in campus sites consisting of a single building. You see that in here is a single building, so at this time we will try to use the two-tier campus network. It means that the three-tier is for the larger networks and two-tier is for the smaller networks, as if you try to explain it this way. Also known as the collapsed core network design. So collapsed core network design, also the two tiers. So these are two terms that we can use for explaining this. Now, a role of a switched network. You see here's access, here's distribution, and here's core. Networks have fundamentally changed from a flat network of hubs, it's correct, to switched line in hierarchical networks. So you see previously, it was like we can use hubs and instead of switches and routers, and it was good, no problem, you can manage. However, nowadays is changed. Nowadays you'll need switches because sometimes you'll have different departments, and you need to make sure that all the packets are not shared with the all the departments. So we will need to use a switched LANs in the hierarchical network. Then the switched LAN allow additional flexibility, traffic management, and quality of service and security. So you might be asked, a switched LAN allow what? Allow flexibility, traffic management, quality of service, and security. It is like the advantages of the switched LAN. A switched LAN may also support wireless network and other technologies such as IP telephone and mobility services. So you see in here, we have VoIP, voice over IP, and like we have printers, and also it can support wireless networking. Okay, so like if we had an access point in here, that access point would be connected to this and it will give us like Wi-Fi. So we will have a Wi-Fi, so we can also connect to it using Wi-Fi, not only the Ethernet, using Ethernet cables. Now we have a scalable network. We will need to explain what does it mean when we talk about scalability. Scalability is a term of a network that can grow without losing availability and reliability. So if I asked you, what do I mean by scalability? You mean that if I have a network and I want to make it bigger, make this network bigger, we need to make sure that we will not lose availability and reliability. So if I have availability and reliability after expanding my network, it means that my network was scalable. So uh, be aware of this two term scalability, okay? When we have scalability, we need to make sure that we have reliability and availability. At this time, we can say that my network is scalable. Network designers must develop strategies to enable network to be available and scalable, scale effectively and easily. So it means that when you create a network, like you need to make sure that you will think of like they would say that now our company have 20, 25 employees. You need to make sure that you think of a 100 employees. Okay, at that time, if you thought about this, you will have no problems. Like for 100 or 150 employees, even if you didn't think of it, you said, well, only access point will be sufficient for you. At that time, when it reaches 30 or 50 employees, there will be a problem back at that time. This is accomplished by using what? Well, scalability is accomplished using what? Redundancy, multiple links, scalable routing protocol, and wireless connectivity. I will try to explain it here, and also I will try to explain also in the other side. Redundancy means if you need one switch or you need five switches, you need to make sure that you will have seven switches in your topology. So if one of the switches goes down, you will have a backup switches, and also same for the router. Multiple links, this will be through ether channel. It means that you will have different links for the same purpose. And so if when one of the links is down, the other links would be used. It's for like a backup. Scalable routing protocol like OSPF, it will be used for scaling if your network is you want to make sure that it's scalable. Uh, OSPF is a good choice. And wireless connectivity, because nowadays we know that nearly all the devices are connected to you wireless, connected to internet using wireless. So you need to make sure that your network would support wireless connectivity. And now you see plan for redundancy would be also, we will try to explain it more in these slides. Redundancy can prevent a disruption of a network. So it means that redundancy will make sure that your network will be available and it will not be disrupted. And of course, through it by minimizing the possibility of a single point of failure. So if you want to make sure that your network will be available 24/7, you need to make sure that it is not a single point of failure. And by doing what? By installing duplicate equipments and making sure that even if, but at that time, if it is not a requirement, you need to still have it because sometimes uh, a switch might goes down with no reason. Okay, so at that time your network would be available still because you have your backup. Providing failover services for critical devices, and we will try to explain also these. Redundant paths offer alternative physical paths for data traverse to network support high availability. So you need to have redundant paths, so it is not only one path. If that path goes down, your network will be down. You need to have also redundant paths. So let's say that through here it can go, or through here, and so on. Also, however, redundant path is Ethernet network may cause logical layer 2 loops. Um, yes, we will have some loops in here. So sometime it might go in here and have a loop in here, return back and goes down. So STP spanning tree protocol for the switches need to be used, so it will block the loop in the switch. Now, reduce failure domain size. A well-designed network, okay, when you create it, if you want to make sure that your network is well designed, it should do this, control traffic and limit the size of failure domains. Example, the area of a network that impacted when the network experienced problems. In the hierarchical design model, failure domains are terminated at the distribution layer. Okay, every router functions as a gateway for a limited number of access layer users. Now, routers or multi-layer switches, so the router and the multi-layer switch, they can both nearly work together and in the same way are usually deployed in pairs in a configuration referred to as a building or departmental switch block. Each switch block acts independently of the others. So we will have like a switch block and it is totally independent, no needing to communicate with the others unless it needs to. As a result, the failure of a single device does not cause a network to go down. So let's say that you have 10 or 5 or 7 networks. You will have each one configured to act as a independent block. So at that time, if one block goes down, you will not have a total system failure, and it is good to some extent. Now you see increased bandwidth. Link aggregation is one of the examples, and we talked about the Ether channel when we talked about the link aggregation or having a duplicate link. Allow administrator to increase amount of bandwidth between devices, creating one logical link made up of a several physical links. So you see, also you may have another link like this or like this. So at this time, one, two, three, and this one's four. We have four links. Using Ether channel, we will make all of these four links as one, and we will have some advantages. One of them would be if these links fail. We will have another link like this and this and this. And also, if this one fail, we will still have two links. Another advantage is we can have a load balancing, and another one would be for the bandwidth. Like if this one, uh, let's say this one is 4 for bandwidth, that time we will have 60 megabyte of bandwidth, and that's a very quite good advantages. Yeah, these points are explaining what just I explained it for you. So it says Ether channel combines existing switch port into one logical link. So we will have two two links, and we will if these are the physicals, okay, and logically we will make it one link. Most configuration tasks are done on the port channel interface instead of individual port to ensure configuration consistency on the links, and it is good for the load balance between the links and so on. Now expand the access layer. An increasingly popular option for extending access layer connectivity through the wireless. And yeah, we explained this one in the previous slides. Yeah, I think in here. Yeah, here. In here, we said that we can have an access layer, an access point, and it would be wireless. So we will connect it to access layer, and in here we can have mobile phones and laptops or any other devices that can be connected to through wireless. So this one is still talk about the same one, the access point or AP. When we say AP, we mean access point. It is the device or the router or modem, whatever you call it, that we can use to connect to the internet. And it would be through the access layer. And it will give us a flexibility, reduce cost, and ability to grow and adapt changing network business requirement. And it makes sure that all the devices can connect to internet through this wireless. However, to communicate wirelessly, device require wireless NEC, wireless network interface card. And nearly all the devices nowadays it has it. Consideration when implementing wireless networks. So you need to be aware of these points. Type of wireless device connecting to the WLAN, wireless LAN, and the wireless coverage requirements. Sometimes if they say that you need to cover like entire campus or an entire faculty, it means that you will need more than two or three or four or any like you may need five. At that time you need to make sure that you have a corrected coverage for yourself. Interference consideration and security consideration, these are the points that need to be aware. Now, tuned routing protocols, as we said, OSPF is a good routing protocol. And in this one is a multi-area OSPF, and we said that among the multi-area OSPF, OSPF in general, the link state routing protocol uses areas to support hierarchical network. Now, OSPF router establish and maintain neighbor adjacency with the other connected OSPF routers. OSPF routers synchronize out their links. Okay, they will synchronize their links as link state database. And when network change occurs, let's say in this router, they will make sure that to tell this router and to tell the area one or like the backbone, and that time there will be again another short path. For example, if this router goes down, if this one goes down, they will create their again their routing table, and they will tell that this is now our best path. Now, switched hardware. Now we will try to explain the type of switch of a Cisco and what are the factors that uh, we can have, or what are those factors that we will have when we design a network, just so we know that we have different type of switch, so we will choose the right one. Now, a variety of switch platforms or different form factor and other features must be considered before choosing a switch. So it's not only one thing. You say, well, 2960 is good and we'll try use that. However, there are a lot of points that need to consider. It is important to select a proper hardware to meet current network requirement as well as allow network to grow. So it is not only for now, you need to make sure that that switch that you will choose, it will support like two or three other updates that you will do over your network. So if you make your network bigger by 2x or 1x, it's supported still. Campus LAN switch like a 3850 Cisco series shown in here. This one you see it has a lot of ports, so this one is a very good one, a very good option for the campus that needs a lot of internet sockets for the users. Now you see in here we have Cisco Meraki. This one is Meraki. Meraki Cloud Managed Access Switch enable virtual stacking of a switch. So this one is the cloud managed access, and it allows you to enable a virtual stacking of switches. They monitor, configure 1,000 of switch ports over the web without intervention of our on-site IT staff. So you have this one, you can configure a lot of switches without going on-site or go to the data center by yourself. The Cisco Next platform promote infrastructure scalability, operational continuity, and transfer flexibility in data centers. Now, switched platforms, yeah, service provider Ethernet access switch feature application, intelligent unified service, and virtualization, integrated security, and simplified management. Now, Nexus Virtual Network Switch Platform provide a secure multi-tenant service by adding virtualization intelligence technology to data center network. And for the Nexus Virtual Networking Switch, it says that it will give us a multi-tenant service. What does it mean? It means that we have a virtualization. We can make that switch to like three different switches. However, we will use the same hardware. However, virtually we will make it three different switches. That's why we will call multi-tenant. Now, when selecting a switch or a network system must determine the switch form factor. This include fixed configuration, modular configuration, stackable or non-stackable. Stackable means that you can just stack it like this. Features and options on a fixed configuration switch are limited to those that originally come with the switch. The chassis on a modular switch accept field replaceable line cards. The chassis need to make sure that the chassis will uh, allow you this. Special cables are used to connect stackable switches that allow them to effectively operate as a one large switch. Okay, so if the switch is stackable, you will need a very good a different type of cable, and that different type of cable will let you to connect them effectively, and they will act as a one single switch or one large switch. The thickness of a switch, which expressed in the number of rack units, this one you need to consider it very good. It's also important for switches that mount in a rack. For example, fixed configuration switch shown in a figure are all one in rack units. Okay, and one rack unit or 1.75 inches or 44.45 millimeter in height. So you need to make sure that you know that one rack unit is 1.75 inches and or 44.45 millimeter. Now, port density. The port density, it means that that switch have a lot of port or not. And the port switch refer to a number of port available on a single switch. Now you see this switch have a lot of ports, and maybe other ones might have 16 or 24 ports. So fixed configuration switch support a variety of port density configuration. Cisco Catalyst 3850 comes with 12, 24, or 48 port configurations. So if you bought Cisco 3850 Catalyst 3850, you may have 12, 24, or 48 uh, ports. Modular switch can support very high port density through the addition of multiple switch port line cards. So if let's say in here you see that this place is empty or vacant, you may have if this switch will support a replacement or adding more ports, you may buy the switch port line card and you will insert it here. It will add more ports to the switch. And in here it says the Catalyst 9400 switch support 384 switch per interfaces. So that only one switch, which is this is the name, it will support 384 ports. Now, forwarding rates. Forwarding define the processing capability of a switch by rating how much data the switch can process per second. So how much data a switch can process per second, it means forwarding rate. Okay, the amount of a data that can be processed in a second, that would be a forward rate for a switch. Now a switch product line are classified by forwarding rate. Okay, so if they ask you how the switched product lines are classified, you say by the forwarding rate. And if they asked you what would be the forwarding rate, you say that the amount of a data that can be processed in a one single second. And entry-level switches have lower forwarding rate than the enterprise level switches. It means that the enterprise level switches are very efficient and they are more powerful than the simple switches, and it is quite obvious. If a switch forwarding rate is too low, it cannot accommodate full wired speed communication across all of its switch ports. And what do I mean by it? The wire speed is data rate that each Ethernet port on the switch capable of attaining. Now, this is the point that I talked about. The wire speed is a data rate. And data rates can be 100 megabyte, 1 gigabyte, 10 or 100 gigabytes. So from 100 megabytes to 100 gigabytes. Now, access layer switches typically do not need to operate full wired speed because they are physically limited by their uplinks and distribution layer. Now, power over Ethernet, PoE, you will hear this one a lot. And what do I mean by this? It means that that switch will send both deliver power on the device, and if there's any other things, it can send it through the cable or the LAN cable. An example would be IP phone or access point or cameras. They will have both power and the data in the same link of the existing Ethernet cabling. A network element should ensure that PoE features are actually required for a given installation. So if a company will ask you for PoE or they ask you for this, yeah, at that time you can use it, because otherwise you should not use it, because the switch that support PoE are expensive, and you need to make sure that you will not use it unless it is required from you. Okay, multi-layer switching. Multi-layer switching are typically deployed in the core and distribution layer of an organization switch network. And they support some routing protocols and forward IP packets at a rate close to the of layer 2 forwarding. Multi-layer switch often support specialized hardware such as application-specific integrated circuits, ASICs. ASICs, along with dedicated software data structure, can streamline the forwarding IP packets independent of CPU. Now, the business consideration for switch selection. So these are the points that you need to be aware when considering a switch or selecting a switch for your network. Cost. The cost, you need to make sure that they will support you for this cost. The switch depend on the number of the speed interfaces, support feature, and expansion capacity. Port density, how much port do you need? The power, if you need a power over Ethernet or you need to just a simple switch. Reliability, this switch should provide continuous access to the network. Port speed, sometimes you may not need 100 GB, so no need for buying it. And of course, 100 GB will come at a different cost with like 10 megabytes. Frame buffers, the ability to store frame is important in a network where you may congested port or servers others area of the network, so you need to take care of the frame buffers. Also scalability. uh, Scalability is one of the most important parts that you need to take care of it. The number of users of a network typically grows over time, so you need to make sure that you'll provide you will provide scalability or the growth for your network through choosing a very good switch. Now, router hardware. Router requirements. Router use the network portion or a prefix of the destination IP address to route packets to the proper destination. Yeah, we know this. We explained it a lot. Now they select an alternate path if a link goes down. All hosts on a network specify the IP address on a local router interface and their default gateway. We explain all of these, and we know what is the default gateway. We know that all if we have a router, it means that we need to have IP addresses, because when we have a router, it means that we have a routing protocol. So we need to make sure that we will have also IP addresses. Now, routers also serve other beneficial function. So it is not only those have also these benefits. Now, they provide a broadcast containment by limiting broadcast to the local network. So there will not be a lot of broadcasters. At the LAN, they may have, or the network may have a lot of broadcasters. However, it is not the same case with the router. The router, or they interconnect geographically separated locations. So let's say that you have two different locations, one of in Arbil, one of Suleimania. Router will allow you to connect these two locations. The group users logically by application or department within a company who have command needs or require access to the same resources. So they will logically group users. Okay. They provide enhanced security by filtering unwanted traffic through access control lists through ACL. We explained it in week 4. They will give us a security filtering. Now, Cisco routers, we have different Cisco routers and branch routers shown in this figure. So these are sorry. Now, these would be, yeah, these are the routers, and they are branch routers. Optimize branch services on a single platform while delivering optimal application experience across branch and WAN infrastructure. This one is ISR for 4000 series. Okay, it can be different, can be 4000, and the rest. And the Cisco routers, we have network edge router. Okay, so these are not network edge routers. as shown in here. Enable network edge to deliver high performance, highly secure, reliable service unit, campus, data center, and branch networks. And now this one is ASR 9000 series routers. And we have a service provider router shown in the figure. And this service provider router means that this one used by ISPs, and they deliver end-to-end scalable solution, subscriber aware services shown in a Cisco network converged system and a 6000 series routers. Now, industrial routers, such as ones shown in this figure, designed to provide enterprise class feature in a rugged and harsh environment. So, for example, this is the in the forests and so on. They will use these uh, routers because they are designed for the harsh environment, and it would be Cisco 11000 series industrial integrated service routers. And this one is 900 series, and this is for a small branch office router, and it combined WAN, switching, security, and advanced connectivity options. And it is without any fan platform for a small medium-sized business. So you can use this router, the small router, for a small or medium-sized business. And we have Cisco ACR 9000 and 1000 series aggregation service router. These routers are provide density and resilience with the programmability. So if they asked you in exam if we want a router or a series of router that can give us density, resiliency, and the programmability, now these all would be for scalable network edge. However, the Cisco ASR 9000 and 1900 and 9000 and 1000 series would be very good for this case. Now we have Cisco conversion system 555 5500 series service router. These routers are designed to efficiently scale between large data centers and large enterprise networks. This would be the usage of this series. Cisco 8000 Industrial Integrated Service Router, and this one is also for the harsh environment, for the environment that is quite harsh, and it would be good choice for this. And we will come to the end of this module. I want to tell you that please make sure that you will have your hands on this one if you want to understand this packet tracer, if you want to understand more about layer 2 and layer 3 devices. It means layer 2 means switches, switch, we have two layers, switch layer 2, switch layer 3, and so on. And in here we have these module practice and quizzes, what we have learned, what are the like borderless network and hierarchical design, access layer, core layer, distribution layer, and so on. Make sure to read also these and wish you the best.